All right, we have an integral of trig functions here. And the key thing to see here is that we have a cosine, there's actually a cosine squared in this and a sine squared in that, which means if we looked at the cosine squared of 2x plus sine squared of 2x, we get equal to 1, which means we can actually do some substitutions. Namely, we have sine squared 2x minus 1. So if I'm going to subtract 1, I have to subtract cosine squared. So sine squared 2x minus 1 equals negative cosine squared 2x. So this is actually just cosine squared 2x with a negative in front of that. So these cancel with two of those, and really this thing is just the integral of negative cosine squared 2x dx. So the integral of this is going to be, well, it's going to be sine, or sorry, it's not squared. We took away the power. We took away 2 powers here, so it's just going to be cosine. So that makes it a lot easier to solve. So we know we're going to have to differentiate sine to get cosine, sine of 2x. And if we took a derivative of this, we get 2 on the outside, so we have to get rid of that by doing a 1/2. This negative is still involved. And we need to get the constant of integration. So taking the derivative, we get 2 out here, that cancels with there. And then we get cosine of 2x, cosine of 2x. And the negative is still there. When we take the derivative of sine, we get cosine. So that all checks out. So the answer is A.